All right, it is now 8 o'clock. So good evening, everyone, and welcome to the Sheikh Abdullah Salim Cultural Center series of talks with the Kuwait Institute for Scientific Research, also known as KISR. Thank you for joining us. I'm Al-Anud Al-Sharhan from the Education Department, and I will be the talk moderator this evening. The talk will be for 45 minutes, and the last 15 minutes will be for discussion and questions. Our guest for this evening is Dr. Badriyah Al Helaili. Dr. Badriyah boasts an impressive resume and is currently an associate research scientist at the Nanotechnology and Advanced Materials program at KISR. She also received her PhD in electrical and computer engineering with concentration in nanomaterials, nanosensors, and nanofabrication. And today she will be giving us an introduction to nanotechnology and its applications. It's a pleasure to have you, Dr. Badriyah. The mic is yours.
Thank you so much. Good evening, everybody. My name is Badriyah Al Helaili. I'm a research associate scientist at Kuwait Institute for Scientific Research, holding a PhD degree in electrical engineering with a specialty in nanomaterials, nanofabrication, and nanosensor for electronics and optoelectronics. I'm so glad to welcome everybody to this presentation entitled Introduction to Nanotechnology and Its Application. This is designed to cover the science behind the phenomenon that arises when considering materials at the nanoscale. Definitely, we need complete courses to understand some topics in depth. However, in this seminar, we will include major topics in nanotechnology. Nanotechnology has received much attention from scientists in the last few years, raising hopes of revolutionary development in wide range of technologies. On an increasing small scale, dramatic improvement to standard of living, and a solution to a variety of environmental, medical, and communication problems. Hence, nanotechnology aims at the design of functional material, a structure, devices, and system through direct control of the matter on the nanometer scale and exploration of novel phenomena and properties at this length scale. So the length scale is defined as being smaller than 100 nanometer, depending on the physical and chemical characteristic of the nanostructure. These nanostructures have novel properties that can be controlled at the atomic scale. We can see here in the figure, which is the scale of things and nanometer scale. In 1959, Feynman thought that in the great future, we would be able to arrange atoms the way we want. This is now possible for some kind of atoms, as we can see here in the scale, on some kind of surface. This graph is a good way to compare the size of different objects, is to place the object on the scale. You can get a feeling on how much thing you can look at the same size, but when you place next to a scale, the real size become more apparent. So if we take a minute to study the object on this chart, we would consider some macro scale, which is very obvious to the naked eye, and the micro, which is in the range of 100 micrometer to 100 nanometer, and definitely the nanoscale, we can see it at the bottom, the scale bar here, which is in the range of 100 nanometer to 1 nanometer. The nanostructure material synthesis method involves two different strategies commonly referred as a top-down or bottom-up approach. So the top-down nanotechnology attempts to reach structure from a bulk material, as we can see here, to create nanoparticles, which is more finer and more precise dimension. This can be achieved basically by more fabrication techniques, including mechanical, thermal process, optical process, and chemical etching. However, the bottom-up technology attempts to build up complex entities by using a self-assembly properties of molecular system. So basically, we require more chemical reactions. The low-dimension nanostructure, it's actually the nanomaterials are defined to have a nanoscale sizes affect the material's ability to acquire the electronic quantum confinements and increase the surface to volume ratio. In the recent years, there's a tremendous interest in the fabrication characterization of nanoscale structure. along with the interest in their electric, magnetic, mechanical, and chemical physical properties, which will be changed with the reduced dimension. Nanomaterials here can be involved in a wide application, which can lead to a large-scale fabrication at a lower cost. Some of these applications include the following. For example, energy, where the nanoparticles are used for solar energy collection and to increase the efficiency of a solid-state lighting. In health, to control the in situ drug delivery and to enhance the diagnostic monitoring and medical performance. In environment, to build a nanosensor array for health and safety, as well to use the nanoparticle-based waste destruction. Also in nano manufacturing is to fabricate a large area performing bottom-up assembly for low waste and building an energy-efficient manufacturing. What is the phenomena with increasing the surface area? When one compares the percentage of atoms on the cube's surface, it is possible to see that as the size of the cube is reduced, the percentage of atoms on the surface increases. It is also the case that the ratio of the surface area to the volume are inversely proportional to the particle size. So we can see here as we move to the nanoscale, the proportion of atoms at the surface greatly increase, and consequently, the properties of atom at the surface begin to dominate to those of atoms in the center of the material. So the properties of the nanoscale material are therefore different than the bulk material. And we can see that there are different classifications of nanomaterials. Depending on the dimension in which the size effect on the resultant properties becomes apparent, the nanomaterial can be classified as zero dimension, in which the movement of electron is confined in all three dimensions, including cluster, quantum dots, nanoparticles, and graphene. One dimension in which the electron can only move freely in the x direction. This can be including the nanobars, nanowires, carbon nanotubes, and nanoribbons. Two dimension in which the free electron can move in XY plane, and this include, as we can see here, the nanofilm and nanolayers. Or three dimension, which is a nanostructure material built of nanoparticles as a building block, in which the free electron can move in the X, Y, Z directions, including the polycrystals, diamond, and graphite. So the types of nanomaterial, there are a number of nanoscale structure have been discovered that are deriving forward many of the emerging technology application. Here we are going to consider some of the important types generally. So the first one here, we have the nanoparticle, which is ultra-fine unit with a dimension measured in nanometer. As we see here in the figure, there are different sizes, shape, and properties of the nanoparticles. Because of their size, they have unique material characteristics and can be used in a variety of areas, including medicine, engineering, catalyst, and environmental remediation. So the nanoparticle can be customized for intercellular application. And the surface functionalization not only is important for the target specific delivery, but also to reduce the toxicity. Hence, we have more selectivity and sensitivity by using the nanoparticles. And it is a great tool to use these nanoparticles for monitoring the cancerous cell and providing a better understanding of its evolution. In the future, these nanoparticles, as we can see here on the nanomedicine figure, these nanoparticles can be mixed in a solution and injected in human body, where we can diagnose and track the cancer cell. And it can be even very helpful for the physician to determine the location of the of the target tumor cells. Next, we have a metal-based material. As we can see, there are different metal-based material. It can be metal organic framework, metal sulfide, metal nanoparticles, oxide, or doped metal with a metal nanoparticles. All of these are precise controlled synthesis of the size, shape, chemical composition, and crystal structure and surface chemistry of metal-based nanomaterials will allow us to obtain a unique properties which have become one of the most challenging issues faced by the nanomaterial researcher. The properties of the nanomaterial are drastically altered in shape and size, making them an ideal candidate for different and wide applications, such as catalysts, energy storage, optoelectronics, sensing, and in biomedicine as well. Next, we have the quantum wire 1D nanostructure, which are the smallest structure that can be used for efficient transport of electron in optical excitation, with 1D dimension are promising for high performance transport devices due to the electron confinement in which the electron have only a single degree of freedom. And this is very interesting for wide application, such as building a transistor sensor in a photovoltaics, photocatalyst, and lithium-ion battery as well. Next, we have also another type of the nanomaterial. We call it carbon-based. And the carbon is a fascinating element because of its different phases and different properties phases exhibit. Recently, various carbon-based materials have been synthesized using a graphene, carbon nanotubes, carbon nanofibers, graphite, diamond, and all these are basically important carbon-based nanomaterial. The graphene is a crystalline allotropes of carbon with a 2-dimension atomic scale with a hexagonal pattern. And it's called the mother of all carbon nanomaterials because it is basic structure element of other allotropes. These materials have a unique characteristic to do their exceptional mechanical, optical, and electrical properties. Hence, it leads to a significant enhancement in the efficiency of the solar cell, nano-absorbent, environmental remediation, in nanobiotechnology, in renewable energy, and also in optoelectronics sensor. Now we will talk a little bit about the nanoscale effect. Different chemical, physical, mechanical, thermal, electrical, optical effects exist, but here we will address some major ones of them. The first one we have here is the crystal structure. Material at the nanoscale can display crystal structure different than those seen by the same material at bigger scale. This is because the effects at the surface start to affect the thermodynamic stability of overall crystal structure. Normally, atoms in a material can be arranged in a number of backing structure, which can be determined by the chemical bonding between the atoms. So we can see here we have non-dense atoms in a random backing, and we have dense regular backing atoms with very low surface energy. So the unit cell is the smallest repeating unit, having the full symmetry of the crystal. As we can see here, we have 3 different cubic cells. The ionic bonds, such as those found in a salt like a sodium chloride, give rise to a cubic backing structure, which is a simple cubic unit cell, while many metals and of atoms behave rather like hard sphere and back in variety closed back structure. It can be whether a paste or body cubic cell. The deviation from these structures are seen when particles have a reasonably high percentage of their atoms at the surface, and the variation in the surface energy start to disturb the forces between the atoms, give the normal equilibrium backing. Next effect we have, which is one of the most important one, the optical effect. The nanocrystalline system have attracted much interest due to their novel optical properties, which definitely different than the bulk crystal. So reducing the dimension of a material to those nanoscale affect its optical properties. And we can see that these properties of a material are determined by what happens when a light wave passes into it. Whether the light is transmitted or absorbed by the material depends on the absorption of the energy of the photon by an electron in a material. For instance, we can see here in the figure that we have different color. And this happened because as the size of the gold colloid decreases, we change its color when the light hits these colloids. So this effect was first observed by Faraday, and they were used the color to sustain the glasses for 100 years before this phenomenon was understood at all. So the optical effect can be clearly very important for wide application in optical detectors, sensor, imaging, display, in photoelectrochemistry, biomedicine, and so many. And these optical properties can be summarized basically here as due to the absorption, the fluorescence, and the photoluminescence effect, which require a complete lecture that will not be included for the today purpose. Thermodynamic effect. Definitely the nanostructure material with their reduced size and consequently high ratio of surface to the bulk of atoms show deviation in many thermodynamics properties as we compare to the same material in the bulk. This is because the surface atoms are bound with a fewer bonds than the atoms some distance inside. Therefore, they easily vibrate thermally rather than the atoms on the inside, and this will lead to a higher probability of melting. It has been observed that the grain size and the shape influence the properties of the material. So as we can see here, these are the grain size and these are the grain boundary where the atoms at this area easily vibrate and have high melting point. So increasing the number of the grain boundaries will enhance phonon scattering, and this will help resulting lower thermal conductivity. The nanocrystalline material would be expected to have a lower conductivity compared to the conventional material. Next is the electrical properties and effects. So this is definitely due to the change of the conductivity or resistivity of the material. We can see here that we have two different SEM images. We observe the different morphology of nanowires or nanosheets of gallium oxide, which were grown with and without using of a silver catalyst. Definitely, the silver catalyst helped us to have much longer lengths of the gallium oxide nanowire. As you see, the first one, which is in the range of 1 to 30 micrometer length. The second one with the silver, it gives much longer, 15 to 70 micrometer in the length. And then these grown material, as you can see here, or nanowire, were coated with a gold metal contacts to measure the electric conductivity. This device has been tested for two purposes, one of them for gas sensor and the second one for UV photo detection. Sorry. The gas sensor. Temperature has an important influence on the sensor resistance. As this temperature increases, the resistance of the sensor drops quickly. Due to the large surface area to the volume ratio of the nanowire, and also the existence of silver nanoparticles at the surface, there will be more trapped oxygen, which makes it more highly sensitive due to the existence of high density of exposed trapped states, what we call them as a dangling bonds at the surface. And these increase the sensitivity and the detection mechanism. The second one, also we tested for IV measurement, the photocurrent for a photodetector was measured at different selected wavelengths, such as 250, 260, and 280 nanometer. So we used 1 nanowatt LED lamps to evaluate the device performance for the detection of deep UV light. Interestingly, the photodetection response with the silver catalyst was improved by almost 2 orders of magnitude. What kind of application that can nanotechnology involve? Definitely there's a huge, but here I select some interesting ones. For a water treatment, the nanoadsorbent has been called as effective and economically attractive technique in industry for a practical wastewater treatment application. The adsorption only attracts ion to the adsorbent surface without penetrating into the material. We can see here in the figure that it shows the adsorbent with the excellent properties absorbs the pollutants, which resulting in less polluted or non-polluted water. The current conventional adsorbent is very limited by the surface area and lack of selectivity and the adsorption kinetics. So nanoadsorbents offer significant improvements to high specific surface area, short interparticular diffusion distance. It enhances the reaction of the surface chemistry between the toxic and the nanoparticles. We also have a tunable size of these adsorbent, which can be controlled in the synthesis procedure. Second, we have a metal-based nanoadsorbent. We have here something we call it a core and a shell. So the core will be made of a magnetic material and the shell made of the silica, which is silicon oxide. And this shell can be used to attract more toxic material and heavy materials such as arsenic, lead, mercury. All of these exist in the wastewater in order to purify these water. So this is another application which is currently under development. The second, we have the carbon-based nanoadsorbent, which is widely used method for home water filter treatment because of its ability to improve water by removing the disagreeable taste and odor, and can be effective against the microorganisms. However, it does not affect total dissolved solids. So there will be some toxic particle exist, even we are using this kind of filter. But the carbon-based nanoadsorbent have shown very high efficiency recently due to the large surface area of the surface. Also, nanotechnology can be in construction. We can see here in nanotechnology in glass. The glass incorporation self-cleaning technology is available already on the market. By coating the surface with a titanium oxide particles, it will help to assure that the surfaces are highly clean. Another idea is the fire protected glass, which is another application. This can be achieved by using a layer sandwich between glass panel formed of foamed silicon nanoparticles, which will turn into a rigid and opaque fire shield when heated. Nanotechnology in coating. Basically, this can be used to, under the paint technology criteria, to create a new paint that can be anti-scratch, UV stable, prevent corrosion, it's non-toxic, can last longer, easy to clean, and also very protective coat. The research is open to assure more environmental use of these kind of paints. Very interesting one, which is we have also, it's the quantum dots. The quantum dots effects are expected to play an increasingly prominent role in the physics of nanostructure, leading to a new class of electronic and optoelectronic devices. So these dots differ in size, composition, shape, and method of manufacture, and these differences that determine their properties. First of all, we can see here different color of these quantum dots due to the change on the size and the photoluminescence effects. So due to its emission spectra, the quantum dots allow labeling and observation of detailed biological process. It also can be used in LED market in order to, because they have ability to absorb and emit at a single wavelength or at desired wavelength. Also, these quantum dots have been used to minimize the energy loss in a solar cell application. So they are really very interesting and unique for a wide application and usage. Our current research. The focus on our research is here to make a sensing nano devices. Sensors are important devices that can detect the presence of target molecule or atoms faster, and it can be highly sensitive and selective to the target. However, the major challenge is how to increase the large-scale production in a simple process at a lower cost. Hence, there is a need to investigate a new material that will be applicable for sensing application. As we can see here in the figure, tremendous industrial challenges are open to investigating new devices that can sustain extreme harsh environmental conditions, such as high temperature, radiation, a high pressure, or vibration. So in order to do that, we can have a look for the nano device map. The nano sensor offers several benefits that make the sensor highly effective in achievable process, unique performance with high sensitivity and fast response, with miniaturization and accuracy. Why we do a miniaturization and for some nanoscale for some devices? Because this will help us to minimize the energy and the material used in manufacture. We will integrate these design with for electronics purposes, reduction of the power budget, and we will have more faster response of some devices, more increase in the sensitivity and the selectivity of such devices. Therefore, it is to measure the sensitivity of any application, there will be three major modules need to be recognized in such like having a receptor, interface, and finally the detector with a digital electronic system. So the target molecule here will be attached to the receptor to detect a molecule by a particular reaction. Then the transducer will convert the detection into electrical signal determined by the detector. Definitely, after building the device and determine the application and having the desired receptor with the target electric interface, we will require to do that a fabrication technique, and we will do characterization of what we fabricated. If we are successful, then we will proceed with the electronic system for the final line of production. This is a nano biosensor for detection of novel coronavirus and other respiratory virus. This is a recent review we have achieved, where we compare many nano biosensor for influenza and COVID-19 biosensor. Simply, the diagram of different analytes, bioreceptor for biorecognition element, and transducer with integrated nanomaterial used for biosensing as a part of nano biosensor for respiratory viruses. The target molecule attached to the bioreceptor to detect the biological molecule by a particular reaction, and then the transducer with integrated nanostructure will convert the detection into electrical signal to determined by the detector. Different nanobiosensor designed for respiratory virus has been included, such as electrochemical, optical, and piezoelectric nanobiosensor. Nanofabrication is a highly important to build electronic device by top-down approach. So the investigation of etching technique is very important for the preparation and the fabrication of devices with controlled micro and nanostructure, especially in the third and fourth system in the periodic table, due to their importance for optoelectronic devices and nanosensor. So creating such as deep holes on the surface of the substrates are still a challenge and require more control to increase the surface area of the substrate to obtain a new different properties. Here is we have very deep hole, which has been achieved by a technique we call it photoelectrochemical etching, to create these kind of deep holes in the surface of the silicon. Here we achieve about 23 micrometer in 30 minutes. Here we achieve about 300 micrometer, which requires about 3 to 4 days of etching. Nanofabrication, again, here we have a hole has been customized for a photodiode application. So it is a high speed and very high efficient silicon photodiode, was determined by enabling light trapping on the micro or the nanostructure hole. These 3D holes has been fabricated on the surface, and we can see here in the plot of the quantum efficiency versus different wavelength that the efficiency has been highly increased from a flat surface of photodetector to the one with a deep holes on the surface of the silicon. So this kind of fabrication is still under development, but it is very challenging. We have also achieved development of a UV photodetector. So the detection of UV light is highly important for different applications, for communication, for space communication, missile tracking, for environmental monitoring, for more chemical or biological analysis. But the traditional devices require very large voltage, and they can be fragile and bulky. And the challenges here is to produce very simple and inexpensive device with a high sensitivity and faster response. Metal semiconductor metal, which we call it as MSM, is one of the simplest process and easy to fabricate. So after we grow the material and deposit a metal contacts, we were successful to improve the UV detection by using gallium oxide based material, which is one of the wide band gap semiconductor. This material was synthesized by using two different substrates, such as a silicon and as well the quartz. Here we have two different semi-logarithm of loss of the current of a dark and photocurrent of a gallium oxide nanowire for a silicon and for a quartz substrate. Definitely we can see that there is high improvement with the one with the silicon compared to the one with the quartz, because silicon, it has the band gap about 1.1 compared to the quartz, which is a little wider. And that's why the photocurrent in silicon can be very measurable. The current, the photoconductivity mechanism of the gallium oxide nanowire is accredited to the surface oxygen absorption and desorption process, which is influenced also by the presence of silver as a catalyst, leading to improve the oxygen detection and the electric properties of these gallium oxide nanowires. Our coming goal is to develop the focus on the gas sensor, which is resistive gas sensing application at higher temperature have been studied highly and intensively. These applications include compensation engine, industrial health and safety, gas and petroleum sector, and also a research purpose. Gas sensors that can be operated at high temperature are essential for monitoring the concentration of the gases that could cause harm upon exposure or lead an explosion or a fire. This will be our focus to the coming research topic. In KISR nanotechnology program, we have a potential and application to focus on wide application in renewable construction, in coating, in petroleum sector as well. We have so many research for water desalination, food backing, and biology. We have also interest to have a new application for Department of Defense in communication, for safety, for the transportation and security, and medical diagnosis as well. In conclusion, So in conclusion, the nanotechnology offers the ability to build a large number of products that are powerful. The nanotechnology industry is mainly used to create a new world. If you are interested in my research, you can find all my work, projects, and the current published research publication in ResearchGate under my profile, Badriyah Al Helaili. This is my email. If you are interested, contact me for any details or for more information about the nanotechnology or nanofabrication. I'll be glad to welcome you to my office. And thank you so much for joining this lecture. I hope you find the material both informative and useful. And I'm welcoming to if you have any questions. Thank you.
Thank you so much for the very insightful presentation, Dr. Badriyah. And you were right, each slide, I think, needs a workshop on its own. It's such dense material, and you explained it so beautifully. And thank you for your invitation as well for anyone who would love to delve into nanotechnology.
Thank you.
And of course, for everyone watching, if you have any questions or input, please type them into the chat, and we will start answering them soon. And while you are typing your questions, we actually had a few during the talk, so I will start with those. So, Dr. Badriyah, what is the exact difference between nanoscience and nanotechnology?
Nanoscience will study, like you are studying the science behind it. You study let's say, for the chemical properties, physical. To be honest, in general, it is nano. Like nanotechnology includes everything. It's the major. But nanoscience will focus mainly on the science behind it, whether it's in the criteria of chemical, physical, biological, etc. However, nanotechnology, it will include the nanoscience, the nanotechniques, the nanofabrication. It's the whole thing in a one package. Yeah.
All right. So are there any startup companies in Kuwait related to fabricating nanomaterials?
No way. No way. It's impossible. Yes, because the nanofabrication or nano, it requires a special customized lab. Unfortunately, this lab, it requires high standard of zero contamination. We call it clean room labs. It's not available in Kuwait. Yeah.
Oh, I see. Inshallah,
inshallah, we are working in this with KISR, but there is some application where you can do it in the lab generally to make a material. But if you want to fabricate the devices, you require to do that inside a clean room. So this is not available in Kuwait.
So I believe we have a question from a student, and she says, what major should I focus on in university to get into nanotechnology?
What's her major?
I'll ask her. Can you please write me your major? She is in AUK and she is still undeclared, an undeclared major.
Oh, this is a huge topic. Is she welcome to visit in my office and we will discuss it together, but I think it's open area. It is very open.
I see. Yeah. So we have another question. We heard about nanomaterial used to make masks that prevent coronavirus.
Yeah.
Are they available here?
How they prevent coronavirus is because there is something we call it a coefficient, a sticking coefficient where the virus can stick on the mask. I think it's still under development. This has been designed by people in Stanford University, but it's still under development. I don't think it's available.
So how exactly would the mechanisms be for that masks? Exactly, it's what you said earlier, and it prevents it?
Something it's called a sticking coefficient. What happens is each material, when it hits the surface, it can attach or deattach. So they fabricate it in a way, for example, let's say the charge of the virus is negative, right? It is negative. The coronavirus is negative charge. So we will develop a mask with a particle, let's say some magnetic particles that have a positive charge. When the coronavirus with a negative charge hits your mask with a positive, it will stick on the surface of the mask. So this is the way I think they are working on it, but I don't think it's available yet.
It does sound amazing, though. I hope that all the essential care workers get to use that if it is available.
Yeah.
So maybe this is related to an earlier question. Do you believe that a career in nanotechnology has a future in Kuwait?
Definitely, yes. But we don't have, I mean, you can have a knowledge behind it. You understand it to build up your own career, whether if you want to go to school or university for teaching, or you want to do some research work. But as a, business, I don't think so, because this requires a huge market, and this is not available in Kuwait.
Again, hopefully for the future, Kuwait 2035, we will have, and you would be leading it like a big nanotechnology center. And our next question is, how small or thin can electronics become, in your opinion, in the future with nanotechnology?
There is a limit. You can't go behind that limit. It's still, it is very complicated, but generally, my devices, they are pretty small, like in the scale of maybe less than 1 micrometer. You can't see it by your naked eye. It has to be seen by microscope. Even they are devices. Yeah.
Are all nanomaterials safe?
No, not most of them not. You have to wear a mask. Some of them could cause a cancer. You need to have a proper safety requirement when you deal with this. That's why we require a clean room. That's why when you go to the clean room, you have to wear a whole, custom gowning when you go inside these kind of labs, because the material there is not safe, and the gases as well, most of them toxic.
So this question is probably a follow-up, and one of the viewers asked, you definitely heard about the conspiracy theory of nano items placed in vaccines. Theoretically, is this possible?
Again.
I was saying that it's also about safety, but this person is asking about the conspiracy theory of nano items placed in vaccines. Theoretically, is this possible?
I'm not in this field in medical, but it could be, but I'm not in the field of medical particularly.
So our second, I feel like there's a lot of safety and ethical questions going on. So this question is, are there any ethical implications to using nanotechnology? Like, is it safe for the environment or not?
It depends. It depends, but so far it is a solution for many applications, and it is very environmentally as you use it. But the hardest thing is how you do it. You require to go in as I said, a clean room, the toxicity in building it. But I think the final output will be safe.
So what can be done if we synthesize nanocomposite powder particles? Can it be done?
Yeah, we do it in here in Kisser. Yeah.
But I think this is someone who's probably has some knowledge of nanotechnology. What exactly is nanocomposite powder particles?
Nanocomposite, basically, you combine two different materials, And then I think you grind it using, we have something we call ball milling, where you smash this into very ultra fine nanoparticles. I'm not interested in that much, nor in materials, but I think we can do it. We have a group of scientists who are working in these kind of nanocomposite and nanopowders, nanometallurgy. It is led by Professor Sharif Iskandrani. I think if he's interested, he can join and have a chat with him one day in Kisser. Yeah.
So we have another question. Can I practice the basics of nanotechnology at home? Like I will try to have my own clean room, or do I need expensive tools and materials to explore it more?
No way. No way. To go access to the clean room, you need to prepare 2 weeks for the exam to be approved to enter the lab. Not only to touch the machines, just to enter the lab. It's very, very complicated, and it is very dangerous for the safety of some people. Yeah.
So, Doctor, what made you get into this field? Like, did you see something that inspired you for it?
No, when I did my bachelor, there was a huge nano lab, and I was so excited. And then when I came back to Kuwait and I joined Kisser, they started the program, and I was one of the first engineers who joined that program. So I had my passion to continue in this specialty, and thankfully, I am the first here in Kuwait who specialize in nano device fabrication. I'm so glad for this. So yeah, indeed, I love it.
That's an amazing achievement. Congratulations on that. That is so impressive.
Thank you.
And we have another question. Who is developing nanotechnology? Is there a certain enterprise that is doing amazing research in it?
Again, I didn't understand what is exactly the question.
Is there a certain company that is developing nanotechnology? And is it open to the public?
In Kuwait?
No, this is globally.
Yeah. There is a huge market working in everything. They work in optics, they work in devices, they work in photodetectors, everything you can guess, in petroleum sector, in solar application, materials, biomedicine, everywhere. And nanotechnology, for example, in my major, I have a specialty in nanoelectronics. Other people, they are interested in nanomedicine. Other people, they are interested in nanoparticles and nanocomposite. So that doesn't mean that we both understand each other. You see what I'm saying? Even we understand the nano and the science behind it, but the specialty is different. It's exactly like when you have a medical doctor, they are different. The same thing in nano. So the people who are in studying like mechanical engineering and they study something in nanofluids, their focus is different than mine. But we understand what is the physics and the effects behind it. It's easy to catch. Yeah.
It seems like such a vast field. There are so many sub-majors in it.
Yes, so you can take your own focus in some section.
And our final question for the night is, does graphene count as a nanomaterial, and can it be used?
Yeah, it is a nanomaterial, definitely. Graphene is a part, that's what I said. It's a type of a nanomaterials. It's under the carbon-based materials. And it has also subsection. You have a graphene, graphite, and also what else? The carbon nanotubes. So it has its own tree. And we have also one specialty in this major, Dr. Maryam Adnan. She is also specialized in this field.
All right, that was all our questions. And thank you so much, Dr. Badriyah, and to everyone. Thank you so much.
Thank you.
Thank you so much for joining us today, and we hope that you enjoyed today's seminar. And we hope to be able to see you soon at Sheikh Abdullah Salim Cultural Center, where you can learn more about today's topic by seeing our amazing exhibits. And stay updated for our upcoming events by following us on our social media accounts. And thank you again, Dr. Badriyah. That was amazing.
Thank you so much.
much.
See you next time.